So as we've seen so far, BGP handles the relationship between autonomous systems. And each autonomous system, as we've learned, is represented by an autonomous system number. Each organization that's multi-homing needs its own unique autonomous system number. The IP address space used by the organization when they're multi-homing comes from either their upstream service provider or from one of the regional internet registries. Now, if we look at the table here, we have a range of the autonomous system numbers in use on the public internet. The entire 32-bit range is defined in RFC 6793, and that ranges from 0 to just over 4 billion, the whole 32-bit range. The original 16-bit AS number range ran from 0 to 65535, but in 2008 this range was extended to the full 32 bits. And if we look in this range, several of the AS numbers or AS number subranges have been reserved. 0 and 65535 are reserved. 1 to 64,495 are in use for the public internet, and we'll find those in use on the public internet today. And then after that one, we have few small ranges which have been set aside for various uses. RFC 5398 has defined two small documentation ranges. One range of 16 AS numbers for documentation falls in the old 16-bit range, and another range of 16 AS numbers falls in the new 32-bit range. We also have the private AS numbers going from 64512 up to 65534. And we have AS 23456, which is the transition AS, which was reserved for use when organizations are connecting with networks that cannot support 32-bit AS numbers configured on their routers. Finally, the public internet range, 65552 up to 419999999 is reserved for the public internet. And the regional internet registries are starting to distribute 32-bit AS numbers from that range. And most recently, we have some more AS numbers have been reserved. Those from 4.2 billion up to the entire end of the 32-bit range. So there are just under 300 million AS numbers now reserved for private use on networks which are connecting to or using IP protocols. The 32-bit range representation is specified in RFC 5396, and that defines AS plain, which is the traditional format, as the standard notation. There were proposals to separate the 32-bit AS number into two 16-bit integers, but those proposals did not find much favor with network operators, and so the industry, by and large, uses AS plain, the standard 32-bit number format for representing AS numbers when talking about router and routing configurations. AS numbers are distributed by the regional internet registries, as I mentioned, and they can also be got from upstream service providers who are a member of one of the registries. And this depends really what the address policies enforce within each registry region. The entire 16-bit ASN pool has been assigned to the registries by the IANA, and around 43,000 of those 16-bit AS numbers are visible on the internet. Now, that's not to say that the other 21,000 have vanished. They are there, they are in use, possibly for private networks or for networks that may be connected to the internet, but we don't have a global view of these ASNs. Each registry has also received a block of 32-bit AS numbers, and out of 20,100 assignments, around 16,000 of these are visible on the internet. That's at the time of October 2017. This number is slowly incrementing as the regional registries are handing out address space. For the complete list assignments, you can refer to the IANA website as shown in the slides. IP addresses are also distributed by the regional internet registries, and they're also available from upstream service providers who are members of the registries. The entire IPv4 address pool has been exhausted now, and each of the 5 registries are operating in their own IPv4 runout mode. The runout mode depends on which registry region the operator is existing in. IPv6 address space, however, is extremely plentiful, and the policies in force at the moment are that network operators receive at least a /32 of v6 address space, and end sites or end users will receive at least a /48 of IPv6 address space. So where to get the numbering resources? As I mentioned, they can be had from the upstream service provider. If in Africa, they can be had from Afrinic. Asia and the Pacific region, they can be had from Apinic. For North America, from ARIN. From Latin America and the Caribbean, it's LACNIC. And Europe, Middle East, and Central Asia is the RIPE NCC. And the graphic shows approximately the regions covered by each of the regional registries. As mentioned when we were talking about AS numbers, there is a range of private AS numbers both in the original 16-bit ASN range and the new extended 32-bit AS number range, which has been reserved for private use. And these private AS numbers have several applications, and we'll look at some of these now. An ISP with customers who have multi-homed onto their backbone will generally distribute private AS numbers to those customers, or may just use one private AS number for all of those customers. And we'll look at that scenario later on in this series. RFC 2270 describes how a network operator would configure their infrastructure to handle customers who are multi-homing onto their backbone. Private AS numbers could also be used by a corporate network or enterprise network with several regions or several offices, but maybe the internet connections are only in the core. This is more scalable than running an interior gateway protocol over a national or multinational network. Each of the regions will operate within a private AS, whereas the headquarters or the core of the network would operate in the public AS number. And of course, the internet would only see the public AS number. Another application is within a BGP confederation, where again the network operator's network infrastructure has been divided into several regions. Each of these regions would use a private AS, yet the network operator would be represented globally by its globally assigned public AS number. It's very important that private ASNs are not visible on the public internet, and so they must be removed from all prefixes which are announced on any peering to the public internet. And our recommendation is to include configuration to remove private ASNs in the external BGP template, as we'll see in the BGP best practices discussion. And the same as with private address space, documented in RFC 1918, private AS numbers are intended for internal use only. They must not be leaked or used on the public internet. The Cisco iOS example configuration is simply to put remove private AS along with the neighbor command when BGP is being configured.